In question number 4, part A, we have a triangle, and in the triangle, the sum of angles should be 180. So we can make an equation that will satisfy the condition that the sum of x, 2x, and 90 degrees should be 180 degrees. So if we simply do the calculations, it will be 3x plus 90 and then 180. Now, if we solve this equation, first we can subtract 90 from both sides. We'll get 3x equals 90 degrees. And then if we divide both sides by 3, we'll get 30 on the right side. So it means the size of x will be 30 degrees. In part B, we have a quadrilateral. And in quadrilateral, the sum of angles should be 360 degrees. So here, the sum of y and y plus 3y plus 4y equals 360 degrees. So we can easily add the like terms. Here it's 7y and 2y, but that is actually 9y. So to get the size of y, we can divide both sides by 9, and that will be 40 degrees. So it means the size of y should be 40 degrees. Now, to figure out the size of z, in case of C, we have this figure. And in this figure, we have a triangle that we can mark with a 1, and this is a quadrilateral that we can mark with 2. So the triangle is actually the equilateral triangle. And in equilateral triangle, all the angles must have the same size. It means 60 degrees. So here, if I mention that this is 60 degrees, then I can easily figure out the size of others. Because here, this one will also be 60. It means this remaining size on the other side, I mean, in the quadrilateral, here, this side should be 120 because of the straight line. Now we can easily figure out the size of z, because in this quadrilateral, the sum of angles will be 360. So I can say z plus 2z plus 120 plus 90 will be equal to 360. So if I solve this, z plus 2z should be 3z, and 120 plus 90 will be 210. Now if I subtract 210 from both sides, so I will get 3z equals 150 degrees. And if I further divide both sides by 3, I will get 30 degrees. So we have got the sizes of x, y, and z in this question. Now let's move to question number 5. In question number 5, part A, we have to figure out the sizes of the angles like ABC and BCD. So first of all, if we consider this triangle ABC, in this triangle, it is an actually isosceles triangle because of these two equal sides. So it means the base angles will be same. It means we can mark these two angles with x because both of the angles must have the same size. And if we consider this triangle as triangle 1, so we can make an equation like x plus 84 will be 180. Their sum will be 180. So we can write 2x plus 84 equals 180. Now, if we subtract 84 from both sides, we'll get 2x equals 96. And if we divide both sides by x and by 2, we'll get the size of x. That will be 48 degrees. So in this way, we have got the size of x, that is 48 degrees. Now, let's mention this angle here, that x is actually 48 degrees. So if we consider this straight line, so on a straight line, the angles should be 180. So this remaining size, because when we will be figuring out the size of angle C, we must have an idea about the CBD, means this B angle. So it should be the remaining size from 180 degrees. So if the size of x is 48 degrees, then its remaining size on this side will be 132 degrees. Now we can easily figure out the third angle, which is actually BCD at C. So to figure out this angle, we will again use the same method that the sum of angles should be 180. So that should be, let's mark this angle as y. So we'll subtract the given angles from 180 degrees to get the size of y. So 180 minus 132 minus 23 equals 34. And they are asking in B part that is the triangle BCD isosceles triangle? No, because its base angles are not same. One is 23 and the other one is 34. So if the two angles will be same, then we can say the triangle will be an isosceles triangle. Number 6, part A, we have to figure out the angle sizes TPQ, PQS, and QSR. Here, first of all, actually, I will do the third part. First I will actually figure out the size of QSR, means this angle. So if I consider the straight line that actually make 180 in total, so this remaining size means the size of QSR will be just 180 minus 148. That will be 32 degrees. Now, if I figure out the size of SQR here, then it will become easy for me to calculate the sizes of other angles. So to figure out the size of Q, I will again consider a triangle. So in a triangle, for actually here, I am calculating the size of S, Q, and R. So to figure out this angle, I will subtract the given angles from 180. So 180 minus 32 minus 32. And that will be 116 degrees. So SQR is 116 degrees. Now to figure out the size of PQS, this angle, I will again consider a straight line. So on a straight line, again, angles are added up to 180. So we will just subtract 116 from 180. So I will get 64 degrees over here. It means the size of angle PQS is 64 degrees. Now to figure out the last angle, that is TPQ. So to figure out this angle, I have a quadrilateral where the sum of angles are 360 degrees. So to figure out that angle TPQ, I will subtract all the angles, all the given angles from 360. So it will be 360 minus 90 degrees minus 148 degrees minus 64 degrees. And that will be 58 degrees. So now we have figured out all the required angles. In part B, they want us to write down that what special type of the triangle is QRS. So in QRS, as we have got two same angles, so this is actually an isosceles triangle where the two angles are same. In question number 7, we are again given the figures, like one we can see here is a triangle and the other one is a quadrilateral. So I can mark the triangle with 1 and quadrilateral with 2. So we have to figure out the missing angles. So in this triangle, this angle is missing. I can mark with X. So to figure out X, I will subtract the given angles from 180. So 180 minus 90 minus 55 degrees. So it will be 35 degrees. Now to figure out the missing angles in a quadrilateral, we have to actually figure out two angles here. I can mark with Y and Z. So we have to find Z, we can consider a straight line over here. So on a straight line, we know that the sum of angles should be 180. So we can subtract the given angles from 180 degrees, like 64 degrees and 35 degrees, and that will be 81 degrees. Similarly, for Y, we know that there is a figure 2 which is quadrilateral where the sum of angles should be 360 degrees. So for Y, we can subtract the given angles from 360 degrees, like we can subtract 99 degrees and then 81 degrees and 59 degrees from 360. So we will get 121 degrees. Now in the second part, means B part, they want us to name the quadrilateral. Like what special type of quadrilateral is this? So basically here the sum of these two angles like Z and 99 is 180, while on the other hand again the sum of 59 degrees and Y means 121 is also 180. It means that these are the two transversal on the parallel lines like CD and AB. So in case of one pair of parallel lines in the quadrilateral, it means it is trapezium, because in trapezium we have one pair of parallel lines. Thank you.